Hi, I'm Audra. We're now getting into the business of analyzing our data in this, our 6th podcast. In each of the test analysis podcasts, we're going to focus on a single test. As with the other podcasts, there are 2 assumptions that we have to make before we move forward. First, you're already familiar with research methods. The podcast series isn't about teaching you what research methods are and how to approach research. You should already know that before you start watching these. Second, you need to have a data set that you're working with. The series is designed so that you watch some podcast material and then try it out yourself. So, let's move into the 6th installment in our series, Running Correlations. In this podcast, after a brief introduction to correlations, we're going to get straight into the demonstration of how to run and interpret the tests. You'll need to make sure that you have your data file set up correctly, your factor analyses are run, and you've completed your data analysis plan identifying which tests you need to do in order to analyze each of your research questions and/or hypotheses. If you don't have all these things accomplished, go back to one of the starter podcasts, 1 through 3. In this one, we're going to spend a little bit more time establishing the background on correlations before we move forward into the practicalities of running them, because frankly, understanding what they do and don't do is essential to understanding how to run and interpret them. What are correlations? They simply describe a relationship between 2 variables. But there are 2 types of correlation. The first type of correlation are positive. So what this means is that as one of the numbers increases, the other does too. In our example here, this tells us that as people's level of education increases, so does their income. The second type of correlation are negative correlations. What this means is that as one of the numbers increases, the other goes down. So in this example, it's suggesting that as students watch more hours of television each week, their GPA decreases. Correlations range from +1 to -1, with 0 representing the weakest relationship, essentially saying that there is no predictable linear relationship between the 2 variables. The purpose of the correlation is to ask if a relationship between 2 variables exists, and that's it. So it's important to note that correlation does not imply causation. Actually, it's a logical fallacy to assume that just because 2 things happen at the same time, one causes the other without additional information. Correlations only describe how the variables are related. You'd have to run in statistics contexts, you'd have to run a different test, for example, a regression, in order to establish causality. This is a really common data analysis error. People will run correlations and then try to assert a causal relationship that just doesn't exist. So, for correlations to run, you need to have scale, interval, continuous, or ratio measures. Keep in mind that if you have categorical data, it doesn't mean that you can't run correlations, but you would either have to dummy code them, and see podcast 3 for learning how to do that. You'd have to dummy code your categorical variables if they have 3 or more levels, or you can just run correlations with 2-level variables. So how do we interpret correlations? Take a shot at answering this question. What is the relationship between democracy and prosperity? So what did you come up with? If you said that it was a positive relationship, you'd be right. As GDP increases, we're also likely to see an increase in the country's democracy index. So we could conclude that the most democratic countries are most likely to have the highest GDPs. Let's try another one. What is the relationship between cost and the number of sales? So what did you say? If you said it was a negative relationship, you'd be right. As cost increases, the number sold decreases. Said the opposite way, if the cost was lower, more would get sold. That's really all there is to interpreting correlations. They're straightforward and they tell us a simple story. When you see correlations in published research, or when you're trying to write them up yourself, this is how you're likely to see them reported. In a big correlation table, and this really stands in comparison to the graphs that we've been looking at. So how do you figure this out? Well, the first column and the top row identify the variables that you're testing. Notice that in the first column, each of the variables is numbered, 1 through 8 in this case. When you look across this top row, you'll see the corresponding numbers 1 through 8. Instead of taking up a lot of space on a piece of paper or on the screen, the numbers are the substitution for writing out the names again. So, if we're looking at this table, number 1 represents the self-enhancement strategy. And if we wanted to know if there was a relationship within an accommodative strategy, then we'd check the first column to see that the accommodative strategy was number 6. Then we go across the row to number 6, and we'd see the negative 0.16 number. Now, how do we know what this number actually means? Let's start with the sign. It's a negative number, so it's a negative correlation. This tells us that as the use of the self-enhancement strategy increases, we're much less likely to also see an accommodative strategy used. But is this significant? Well, take a look at these two asterisks. And in order to know whether it was significant, we have to go down to the table notes. And the two asterisks represent that it was significant at the 0.01 level. So yeah, it's very significant. We would be confident saying that if we saw the accommodative strategy used, we wouldn't be likely to see a self-enhancement strategy used. Now, try one on your own. What is the relationship between routine communication and antisocial or defensive strategies? If you said that it was an insignificant negative relationship, then you'd be right. So we take a look at number 2, routine communication. We see that antisocial is number 5, and we come right over here. It's negative, but as there are no asterisks, we know that it's not significant. With correlations and correlation tables, it's just easier to report all of them than to only pick out the ones that are significant. Now, we use the correlation table instead of writing it up longhand in our results section when we have, like this one, a lot of significant relationships. It gives you a quick snapshot rather than writing lots and lots of sentences about whether something is or is not a significant correlation and the direction of it. It's just more efficient and a little bit easier to take in. Now, the last thing you're probably wondering about this table is why is only the half of it filled out on the diagonal? Well, basically, if you look at this, it'd be a mirror image of each other. So again, this is a cleaner, easier way to read it, but that's also not redundant. So, we have our data set open, and because you're not doing anything to your data file and we're just running the statistics, it's easier to just keep the spreadsheet minimized and work directly off your output. So our output is just opened, and let's save this as our correlations. So, remember from our data plan that we identified research questions 3 and 4 as needing regressions. However, like I mentioned in podcast 3, in order to run the regressions, we really need to run our correlations first to identify if a relationship even exists between our variables of interest. Now, the nice thing about correlations is that because the test doesn't specify independent or dependent variables, you can just run all of your correlations at once if you so want, and that way you don't have to keep running them. So we're going to do that. So let's go up to Analyze, then come down to Correlate, and over to Bivariate, and we have our pop-up box. Now, across here we have our 2 questions of interest. And so let's get our variables all entered in. So we need perceived knowledge and behavioral intention and the post-crisis. Then we also need the cultural appropriateness of the response. We need the post-test on the crisis, the reputation. We need blame attribution, which is up here. And then we need post-crisis perceptions of the airline's competence in health and safety. And so we move all of those over, and we double check. Oh, we also need the post-test negative word of mouth. Now, you notice that how it put them over there. Let's say I want to keep them in the same order that they would be in the research questions. You can simply shift these around by dragging and dropping. So let's do that now. Let's put the post-test negative word of mouth. Let's check for the next one that we want is the cultural appropriateness, then the blame attribution, reputation, and the airline competence. You can put them in any order that you want. I like to just keep them in the same order for running them because it makes it easier when I'm translating the data from the output into my tables. So, under options, we only select the means and standard deviations so that you have the descriptive for the variables to report in your methods section later, and you click continue. You don't need to click anything else, so just hit OK, and we get our table. Alright, so let's remember to save our output. So we just have 2 boxes. In the first box are our descriptive statistics. Keep track of those because you'll need them in your write-up, but we won't be using them for the interpretation. So, in the background of correlations, we went through a basic correlation table. Let's make this a little bit bigger so that we can see all of them at once. So this should look familiar. Now, the SPSS table just isn't as condensed, but we use it in the same way. So let's see if there's a relationship between perceived knowledge and consumers' behavioral intentions towards the airline so that we can run our regression later. Try this one on your own. So what did you come up with? Is there a relationship between perceived knowledge and behavioral intentions? If you said yes, and it's positive, then you're absolutely correct. How do we know? Well, let's take a look. So first, we find perceived knowledge. Then we go across in our row to the behavioral intention. And we see a positive correlation, because there's no negative sign in front of it, of a 0.55. Now, this is a very strong correlation, and this is confirmed when we look at the double asterisk, or we can even look at the significance itself there. So the particular significances on the SPSS tables are all listed, as are the single and double asterisks like we saw in our table for the background section. So, with the strong correlation, we've answered that first question, is there a relationship between the two? And that's really all there is to running the correlations themselves. They tell a fairly simple story. As one goes up, the other goes up, in the case of the positive ones, and as one goes down, the others go down. So you can take a look at, and pause this presentation, if you want to take a look at the other correlations and try saying this single sentence, there is a strong positive correlation or there's a strong negative correlation. So when we're talking about telling the narrative of the story, the narrative of the data, this is what we're talking about. Just making it simple, effective, and boiling it down to what the narrative really needs to be. So, if this is all there is to writing the correlations, then how about reporting our correlations? Let's take a look at that. So there are basically two things that you need to report with correlations. First, our background gave you the basics on how to report them. Let's go quickly through the verbiage and the tables to make sure you're ready to report them. You're going to start by telling them what type of analysis was conducted in order to ensure that your reader is clear. So you use a very standardized text for this. It's really a matter of writing the same basic sentence as you report your results. So in our case, you might say, a correlation was run to establish if there was a relationship between perceived knowledge of an airline and consumer behavioral intentions towards the airline after the introduction of a crisis. Or in the case of our other research question, we would say something like, a correlation was run to establish if there were relationships between the perception of cultural appropriateness of crisis response, reputation, attribution of blame, and perceived competence in health and safety as compared to the consumer's intention to speak negatively about the airline, that is, negative word of mouth. The second is that you simply need to fully report your results. There are two ways to do this. First, if you just have a couple of correlations to report, it's more efficient just to write them up in text. So for research question 3, we're only looking at a single correlation, and that's just to get us to our regression, so it wouldn't make sense to put in a table for that. We'd use this approach. So the R in this is what we call the correlation value. It's the abbreviation in statistics for a correlation when it's written out. And then we also write in the p-value, our significance level. However, for research question 4, that's asking about the relationship between a number of variables, you may want to use a full correlation table, especially because there were a lot of significant correlations in that table to report, because that's the most efficient way when you have a lot of variables and a lot of correlations. So at the very least, when you're reporting your correlations in text, you do have to report the correlation value, but you give a quick overview sentence. So in our case, there were significant positive correlations between, you insert your variables, and if you have them, significant negative correlations between, insert the variable names, and see table, whatever table number it is, table X. So with correlations, whether it's in your tables or whether it's in the text, what you need to make sure that you indicate is the R value, the P value, and the variables. So if we come back to our research questions, these are the ones that we set up that needed to have the regressions run. So we're starting with our correlations to know whether or not to proceed to the regression. From here, reporting results in the results section is just a matter of plugging in the numbers from the table in SPSS to the text or to the table that you're creating. So your full sentence, if you have just a couple of them, would look something like this. Or substituting for our numbers, we might say there was a significant positive relationship between perceived knowledge and behavioral intention with an R of 0.55 and a P less than 0.00. Or, if we're using the table as we would for research question 4, you would say there were a significant number of positive correlations between negative word of mouth and the negative evaluation of cultural appropriateness of the response, blame attribution, and reputation. See Table X. Now, how did we get to the 0.55? Well, like we said, that's just the number. We put it in, and the P is less than 0.00. You could also report this as less than 0.01 if that's what your notes denoted down at the bottom, that you put the note 2 asterisks is less than 0.01, 1 asterisk is less than 0.05. So either way is completely appropriate. So let's take a look at the table. This table uses the mirror image compared to the one that I showed you in the background on correlations, just to show you that it genuinely doesn't matter which side of the table that you use. It all comes out the same. Now, when I have a single variable of interest for a research question or a hypothesis, like we do with the negative word of mouth, I like this one because I can look down just the first 2 columns and I get all of the key results that I really need. Also, you'll notice that I've included the actual number of each of the correlation tests, how many participants there were. Both versions of the correlation table are perfectly acceptable. So, why have I included the number in this case? When you're reporting a very large or a very small sample, it can help the reader to understand your results a little bit better. So in the case of a very large sample, when we have correlations like 0.43 or 0.80, it gives more credibility to our findings. In the case of a small sample, we may have strong correlations, say a 0.29 or something like that, but they aren't significant. It can help to explain to a reader, if you report the number, if you have a small sample, that even though the correlation might be strong, the sample size was just too small to identify whether the relationship itself was significant. It's all about decision making, so if you have a strong correlation but a small sample, when you're going on to your regression, you may choose or not choose to include it, depending on your decision making and what you think makes the most sense for the data that you have. Now, that's it for podcast 6 on correlation. For our final podcast, we'll be taking these findings from the correlation tests and running regressions from them.